you guys have the same function as a question.
No, we don't.
Yeah, 15.
You just have to plug in the values that they give you on each endpoint of your interval.
So one has to equal.
You want one to be negative and one to be positive for it to be an answer. If they're both negative or both positive, it's not an answer. Okay, section 2.3. I think you guys will like this section a little bit better.
Probably not.
Division, you guys should have seen this in high school. This should be familiar to you. This is another review section. Starts on page 138 in your textbook. So we're talking about polynomial division and synthetic division. You may or may not have seen synthetic division, that's okay, but polynomial division should be familiar to you. If not, we're going to make it familiar to you. The reason we talk about division is because we have to factor things like this. How do you factor that? I personally don't know. Can you use your quadratic formula for it? Probably not. Quadratic formula works if it's a degree 2 polynomial. This is a degree 5 polynomial. Quadratic formula doesn't work. The only thing I can do is guess values that are 0 and try and do long division. Quadratic formula works on a degree 2 polynomial. This one's a degree 5. Quadratic formula won't work.
True.
So, guess and check, doing long division is the only way we can do this. And we're going to get to how to do that in a little bit, but let's talk about long division. It says divide this whole long thing by x minus 2 and use results to factor the polynomial completely. Long time ago, I think this was probably 2nd or 3rd grade, someone should have taught you how to divide. Yeah. You have to figure out, well, let's make it a little bit easier. My brain isn't that smart.
Yeah.
How do you figure out, okay, does 9 go into 4? No. Does 9 go into 49?
Yes.
How many times?
What? No.
5. Your brain works. I was in a geography class in elementary school, and they had a big map up on the wall, and they lined us up over on one side of the room, 2 at a time, and we were supposed to go to the map and identify a country, and they gave us a country for it. Now, this wasn't something, like the United States and Canada and Mexico, and big countries. We're talking about Europe. Everything is little tiny countries. And I went running across to the map. I tripped, ended up pointing right on the country when I landed on the wall. That's pretty lucky. Good guess there. That was the whole point. 5 times 9 is 45. Then what did we do? Subtract. So that was 49 minus 45 is 4, and you brought down the 3, and you went 9 into 43, and that went 4 times. And you had a 36. Subtract that, 36, so it would be 7. And now there's nothing more to divide. So we wrote 54, and the remainder was 7 over 9. That was how we wrote our answer. Or you wrote it as 54, remainder 9. Okay, we remember that from grade school. Here we go. Exact same process. Exact same process. Now, you want to make sure you fill out for all your powers. If there are any missing powers, you're going to put zeros. There are no missing powers, so I'm just going to write them down. And now I'm going to base it all off of the x here, not off of the 2. So, does x go into x squared, or x cubed, 6x cubed? Yes, how many times? Yeah, 6x squared. And now I'm going to multiply that by the x minus 2. So 6x squared times x minus 2. Just like I multiplied the 5 times the 9 to get the 45, I'm going to do the 6x squared times everything. So that gives you a 6x cubed. And what is 6x squared times your minus 2? Negative 12x squared. Now we subtract it. What is 6x cubed minus 6x cubed? 0, and that should always be 0. Then minus 19x squared, and I have a minus and a minus makes it a plus. So minus 19x squared plus 12x squared is what? Negative 7x squared. Bring down your next term. Start again. How many times does x go into negative 7x squared? And negative 7x, power is 1 there. Multiply now our negative 7x times everything. You're going to have a negative 7x squared plus a 14x and subtract. The negative 7x squared should cancel. You have 16 minus 14 is what? So 2x. Bring down your minus 4. How many times does x go into 2x? 2, right? Multiply the 2 through. You get 2x minus 4. Subtract. Remainder is 0. That is a nice clean one. So our answer is 6x squared minus 7x plus 2. Now, it says use the results to factor the polynomial completely. So that means our polynomial 6x cubed minus 19x squared plus 16x minus 4 is equal to x minus 2 times 6x squared minus 7x plus 2. And the question is, can we factor that last one? Okay, quadratic formula. So use a quadratic formula. You're going to have minus a minus 7 plus or minus 7 squared minus 4 times 6 times 2 all over 2 times 6. So that becomes 7 plus or minus. 7 squared is 49. And 4 times 2 is 8. 8 times 6 is 48. Oh, look, it's going to work out nicely. What is 49 minus 48? 1. So we have 7 plus or minus 1 over 12. Square root of 1 is 1. So this would be 8 over 12 and 6 over 12. So if I'm factoring this completely, I'd have an x minus 2, I'd have an x minus an 8 over 12, and I'd have an x minus a 6 over 12 from the quadratic formula. If you want to use a quadratic formula when you get down to a degree 2 polynomial, feel free. You certainly may. Now it's factored completely. Any questions on that division process? Question?
So if, like, let's say you had, it was x, or it was 6x to the fourth, but then it jumped to 19x.
Put a 0.
We just put it right.
Put a 0 in there. In fact, I'm going to do that. I think that's the next question. Yeah. Our division algorithm, we really don't care about this. This is just saying that you can actually do long division. Come to abstract algebra and I'll prove it for you. But it's saying you can do long division. When you're dividing, make sure that you write these in descending powers of your variable. Start at your highest and go down to the lowest and put your 0 coefficients in there for your placeholders. Here's the next one. Divide. So x minus 1 goes into x cubed, but I'm missing an x squared. So I'm going to say 0x squared, and I'm missing an x. And then we go down to 1. So that has everything down there. Now we start the whole process. How many times does x go into x cubed? X squared, and I just wrote it cubed. X squared times multiply. So you get x cubed minus x squared, and then subtract. The x cubed goes away. This is a 0 plus a 1. So that's just going to give you an x squared. Bring down your x. How many times does x go into x squared? X. Now I'm going to multiply that one. So that becomes x squared minus x. Subtract, the x squareds are going to cancel, and this becomes a plus x. Bring down the minus 1. How many times does x go into x? 1. So I get an x minus 1 when I multiplied those 1 through. Subtract, and they both cancel. You have a remainder of 0. So your answer for this one is x squared plus x plus 1. Long division.
No.
Notice they didn't put it in order. I copied this one from the book. They did not put it in order. So let's put it in order. Does that hurt your head today? 4x
It
cubed.
was like nice little ones of boom.
Yeah, we say the hard ones for you to do, right? So minus 5x squared plus 3x minus 2. Now you can do it. Now it doesn't look quite so bad, right? It actually ends up being relatively simple because you have 3 terms right here. So it ends up being fairly short. So what, how many hits would multiply squared to be plus? So you're figuring out the one that has 7. And then you're going to multiply that times 2x squared plus 2x squared. 2x to the 4th. And then 2x squared times 2x is 4x. And then you probably should put a plus sign. And then 2x squared times 3
Is negative. Yeah, negative 5.
negative 6. Multiply that 2 times 3.
Oh, yes.
Now you have to subtract it all. You have negative 5 minus and minus becomes a plus, so negative 5 plus 6 is actually positive 1.
Oh.
X squared. Now bring 2 more down because you have a total of 3, so bring the 3x down and then put that. And that should be plus 8, right? And then repeat the process.
For the 2x or?
No, everything based off of this one.
So,
How many times how much time would 9 x squared?
oh, so you divided it again? Okay, so then that'd be 1.
Except you have to put your 1 up here, it's actually minus 1, right? Because minus 1 times x squared is and then you have to multiply everything.
Up here, I mean down here, the 2x
You're gonna multiply this minus 1 times all of these and put them down there.
So, negative 1 times x squared, and then this, and then this. Okay, so that'd be negative x squared.
You should put that in the
You should try to get x squared. Negative
What is
And that'd be positive.
Yes.
Okay.
Then you have to subtract nothing.
That was negative.
Now it's negative, and that would be positive, so that would go away. The 3, and then it becomes minus gives you the plus. So that is minus 2. And then that makes up negative 3, so negative 2 minus 5. And then there's a squared, that's a 5x, so you can't really look at
Okay, so is your X.
There's no, you can't multiply x squared by anything but
Mean to
Oh, okay.
So now you have to do that. So then your answer becomes 2x squared minus 1 plus 5x minus 5.
Wait, plus jump?
That is. Is that what you guys got?
No.
I got that first number though. I got the 2x squared. After that.
Oh, see, I knew it was a plus.
Wait. I knew it was that. No. No. Can we just like do it?
How many times does x squared go into 2x to the 4th?
2x squared.
2x squared. Then what do we do with the 2x squared? Multiply everything. So 2x to the 4th plus what? 4x cubed minus 6x squared. Subtract. What happens to your 2x to the 4ths? Cancel. And then you have 4 and 4, and that has a minus, so cancel. And then you have minus 5 plus 6. What does that become? X squared. And then bring down your next 2. And you have to bring down 2 of them because you have 3 things over here. So you bring down the next 2. And then how many times does x squared go into x squared? And so you're going to have x squared plus 2x minus 3. Subtract off. What happens to the x squared? Cancel. 3x minus 2x. Minus 2 plus 3. So then our answer is 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. How did I know to stop right here? There's no more x squared. The degree here is smaller than the degree that we're dividing by, so you have to stop. That's very correct. Okay, now do we all have the right answer? There's one very similar to this on the test.
Oh, sorry, guys.
Not yet. Not till Monday. You can cry on Monday. You'll know how to do this by Monday. You got lots of long division on this homework.
Yeah.
Okay, so suppose I had given you something that looked like this. Now, watch, this is going to have a slightly different pattern, and I'm doing one like this because you're going to have a homework problem like this too. That x squared, how many times does x squared go into x to the 4th? Yeah, 1x squared times. Multiply your x squared through, and you have x to the 4th. And then x squared times 1 gives you an x squared, so you have to line it up over on that second, on that third column over. Subtract it. The x to the 4th cancels. This gives you a x squared right here, but now you have to bring this one down. So this becomes a 3x cubed plus an x squared, and I'm going to go ahead and bring the plus 1 down because I know it's going to skip that x squared term. How many times does x squared go into 3x cubed? Oh, I forgot the x term. Let me write a 0x in here. Because I'm going to need it. So 3x, this gives you a 3x cubed plus a 3x. Subtract them. Now you have a negative 3x from this one, adding straight down. But now we have to bring this x squared down and this plus 1 down. So I just bring them all down. When it skips a degree here, you bring it down. When it skips a power, not a degree. When it skips a power, bring down everything as you're going down so that you can line them up with what you need it lined up with. And then how many times does x squared go into x squared? Once. Multiply, you get x squared plus 1. When you subtract, those cancel, that cancels, this comes down, you get a minus 3x for your remainder. So your answer would be x squared plus 3x plus 1 minus 3x over x squared plus 1. Question?
At the very top, how did you get 3x cubed plus 2x? Because it's 2x cubed and then. Oh, yeah.
How did I write this down? Is that what you're talking about? Or
Oh, right. See where it says 2x cubed? I just realized it was 2x cubed, wasn't it? X cubed.
yeah. Any other questions on that? I will post this on eClass after class today, right after we're done with the lecture, so that you can come back and look at this one. You're going to have a homework problem that's going to have a difference of a degree there. It's going to go from an x squared down to a number, no x term in there, so it's going to have to be done like this one. Okay. That's long division. Now, you have another homework problem, and it says, use long division to divide. The unfortunate thing is they write it as x minus 1 squared. The only way to use long division is if you FOIL that out first of all. So we have to multiply the x minus 1 squared. So I'm going to multiply this way. You have minus 1 times a minus 1 gives you a plus 1. You have a minus x. Multiply your x's, you get a minus x. Then you get your x squared. So I actually am going to have x squared minus 2x minus 1 dividing into 2x cubed minus 4x squared minus 15x plus 5. Yes, I do. Today I have a habit of losing my minus signs. Just change them. Who needs them, right? Okay, so what's our first step? Yeah, to get the 2x cubed, you actually have to multiply by a 2x. So I'm going to have a 2x cubed minus a 4x squared plus a 2x. Subtract it. The 2x cubed cancels. The 4x squared start canceling because they have the same sign. So you have a minus 15x minus a 2x. What is that? Minus 17x, right? 15 minus 2, minus 15 minus 2 is minus 17. Then plus 5. Can you multiply x squared by something to get an x? No. So our answer is 2x plus a negative 17x plus 5 over, I'm lazy, so I'm going to write it as x minus 1 squared instead of the x squared minus 2x plus 1. You could write it either way and it's fine. That's how you have to do that one. It doesn't work so well if you try and divide it twice by x minus 1 because you also have to divide your remainder term. And that becomes a bit tedious. So FOIL it out first and then do your long division. It works better that way. Can we do long division now? Hopefully. Synthetic division. Synthetic division only works when you have linear terms that you're dividing by. So x minus 1, x plus 100, things like that. But it cannot be x squareds or x cubes. You cannot have x to a power. It has to just be an x term that you're dividing by. Your divisor is what you're dividing by. We're going to have a process. We're going to bring the first term straight down, and then we're going to change the sign on the number, and we're going to use that value. This is actually takes a very short amount of paper to do these problems when you do synthetic division, which is why people like doing it. You can do it all horizontally instead of vertically. So let's do the process. What we're going to do is I'm going to copy all of this down first, but no x's. Just write the numbers down. So what's the number in front of our x to the fourth? 1. This is like a 1x to the fourth. So I'm going to write a 1 down. What's the number in front of the x squared? Are we missing an x cubed term? Yes. So we're going to put a 0 for our x cubed, and then a minus 10 for the x squared. Then an x is a minus 2, and then the 4. Now we have all the terms. I'm going to make a little box. Change the sign to the opposite of what you see there. So if it's a minus 3, you're going to make it a plus 3. Always change that sign, because remember, in long division we subtract. What we're going to do is change the sign right there and add. That takes care of the subtraction process for us. So I'm going to make this a negative 3. Bring this 1 straight down and do negative 3 times 1. And now add. So negative 3 times 1 is negative 3. Add to 0 and you get a negative 3. Then we do negative 3 times our negative 3. That's a positive 9. Subtract from 10, and what do you get? Negative 1. Then we do the negative 3 times that negative 1. And that's 3 minus 2. And then we do our negative 3 times that previous answer of 1. That's a remainder of 1. And we always put this box here. This is our remainder term. So our answer, this would be just our constant. And then this becomes a minus 1 times x. And then this becomes a minus 3x squared. And then that becomes an x cubed. You increment your power up by 1 from left to right, starting with the constant term. And then plus 1 over x plus 3. That's the process.
Why isn't the remainder negative 1?
Because this is a negative 3 plus a 4. No, we're adding. We changed this sign right here so that we can add. And so you just add straight down. Okay, let's do another one. I'm going to post these back up here so you guys can come back and get them. Before you guys do one, I want to do another one. Now let's do the checkpoint together. How about that? Yeah. So, what is the first step? What do we write down? The integers. Do they have all the powers here? Yes. So we're going to have a 3, an 8, a 5, and a negative 7. And then you draw that box. Remember, it's an upside down long division symbol. And what do we put on the outside? Negative 2. Change the sign of that 2. Then that 3 comes straight down. And now you do negative 2 times that 3, and what do you get? Negative 6. Add that to the 8. And then what do you do? 2 times negative 2, which is a negative 4. Add that to the 5. What do we get? 1. Then what do we do? 2 times a negative 1, so it's a negative 2. Add that straight down, negative 9. So what is our answer? We're going to have a 1 plus a 2x plus a 3x squared, and then plus a negative 9 over x plus 2. You guys understand the process for synthetic division. Synthetic division is going to be your best friend, and we're going to use it extensively when we get to section 2.5. In 2.4, we're going to be doing complex numbers, so we'll take a break from synthetic division. Okay, there's our answer. We already wrote it down. Now, this is going to be our first beginning of using synthetic division. The remainder theorem says if you divide a polynomial by x minus k, the remainder is f of k. Plug in k, it will give you the remainder when you divide it. We're not proving this theorem. It's actually a very profound theorem. If you had, x to the 100 plus 99 x minus 1, and you want to divide it by x minus 2, your answer is going to be equal to, if this is our f of x, the answer is going to be equal to f of 2, your remainder. The remainder is f of 2. It doesn't seem obvious that that should be the way it works, but that is the way it works, and we're not going to prove it today. So for a factor theorem, if x minus k is a factor, then f of k has to be 0. It has to have a remainder of 0. And you know that f of k is the remainder when dividing by x minus k. So let's see how to use this theorem. It's actually kind of entertaining. The remainder r obtained in synthetic division by f of x provides the following information. The remainder r gives the value of f at x equals to k. In other words, f of k is our remainder. If the remainder is 0, then x minus k is a factor. If the remainder is 0, then k is an x-intercept. That's what it's saying. These two mean the same thing. So now let's talk about factoring. Use the remainder theorem to evaluate the following function at x equals to minus 2. So they're saying find f of minus 2. Well, we really don't feel like plugging in minus 2 to those powers. And I could make those powers be humongous, so your calculator would have devaluated it for you. And it really doesn't like large powers of large numbers. Most calculators will have 10 spaces for their numbers, and then they switch into scientific notation after that. If I make it big enough, then your calculator will give you an approximate number using scientific notation. May or may not be accurate depending on whether I give you a whole number or a decimal value. So we have to have an alternate way of finding it. The alternate way of finding it is actually synthetic division. So let's write it down. Notice I have an x cubed, an x squared, and an x, so I'm not missing any terms. So write them all down. What are we dividing by? If this was in factored form as a 0, I'd write it this way. That's the same thing as an x plus 2. So I actually am going to use the minus 2. When you're doing an x equals, then you just plug in the value that you're checking for. Okay? Bring your 3 down, and what do we do for our synthetic division? That becomes a negative 6. What is 8 minus 6? 2. Then what do we do? Multiply, so negative 4. What's 5 minus 4? Then multiply, and what do you get? Yeah, you guys probably recognize this as the one we just did, right? Yeah. If not, we did it again. What is our answer? Our remainder, sorry. The remainder is equal to negative 9. So then that means f of negative 2 is equal to a negative 9. I guarantee you that's going to be a lot easier than trying to plug in some value into humongous polynomial. Okay, so synthetic division, one of its uses. That one did answer the question, right? Yeah. Use the remainder theorem to evaluate it, so we did. Now, example 6 says, show that x minus 2 and x plus 3 are factors of this big old long polynomial. They gave an algebraic answer and a graphical answer. We're not going to mess with the graphical answer right now. We're just doing the algebraic answer in this section. So what I'm going to do is I want to divide by these values and get a remainder of 0. Let me copy down. Notice it's fourth, third, second, first. So I have all the powers. So it's 2, 7, -4, -27, -18. And then let's check this one first. It's x minus 2, not x equals. So I change the sign and I use the 2. Bring that 2 down. 2 times 2 is what? 4. 7 plus 4 is 11. 2 times 11? 22. Subtract 4. 18. 2 times 18 is 36. 36 minus 27? I think that's 9. Yeah, because 27 is one bigger. Then 2 times 9? What's your remainder? Remainder 0 says x minus 2 is a factor. So I know that worked. Now watch very carefully. I'm not going to go back to the original question. I'm going to use the last answer that worked. Because what's happening is I now have x minus 2 times 9 plus 18x plus 11x squared and plus a 2x cubed. I have this written in this form, x minus 2 times something. So I'm going to divide this by the x minus 3. Don't go back to the first one because you'll just chase yourself in a circle. It's kind of like Joshua wandering around the city 7 times before they went in. We don't want to keep wandering around our city. We want to go into our city the first time. So use the next one. Don't use the previous one. It won't get you anywhere. So I'm going to use this one. It's a 2, an 11, an 18, and a 9. Now we're looking at x plus 3. So what do we put down? -3. Bring the 2 down. What is 2 times a -3? -6. 11 minus 6? 5. -3 times 5? 18 minus 15? 3 times a -3? What's your remainder? So the remainder is 0. So that tells you it is a factor. So what that tells you is that your polynomial looks like x minus 3 times x minus 2 times 2x squared plus 5x plus 3. I'm almost done factoring my polynomial now. I have a quadratic term right here, and you can use a quadratic formula to finish it. Now, if I had told you at the beginning to factor that, would you have been able to factor it? That's why we're using synthetic division. It's going to be our tool for factoring these polynomials. It's only the first half of our tool, though. The 2.5 is going to get to the second half of the tool. We have to talk about complex numbers first before we get there, but this is our first part of our tool. Okay, use synthetic division to divide these. Do we have any missing powers here?
Yes.
Yes, so we have a 3, then a 0 for the x squared, then a 0 for the x, and then our minus 1. Now, this right here, I have a 2 times 2x plus 1. It has to be in the form of something x minus or plus something. So if I factor the 2 out, what do I have left inside? Plus 1/2. So I have to change the sign on that, and what do we get? -1/2. So we're going to divide by our -1/2 and bring our 3 down. 3 times -1/2, -3/2. Add that to 0. -3/2 times -1/2. You divided 3 over 4, right? So positive 3/4, add, you get 3/4. Multiply by negative 1/2. Negative 3/8. Add 1. This is like a negative 8/8 plus a negative 3/8. Negative 11/8. So what do we get? We get 3x squared minus 3/2 x plus 3/4 minus 11/8 divided by 2x plus 1. It looks ugly, but whenever you have that constant times the x, you have to factor it out, and then you can do your division. Any questions on that? Okay, that is actually our last example. We are done.